Hey everyone, continuing for trigonometry integration, we'll start off with an example. So the example is sine 3x cosine x. Okay, this got a lot more weird, right? Because it's a product of two different trigonometrical functions, and it seems like we can't use the power rule, right? Because if you try to integrate to cosine square x, your derivative is minus 2 sine x, right? So it doesn't work because my other trigonometry function is sine 3x. So it doesn't work for this, neither does it work for, well, changing it to sine squared 3x. So I have to divide by 6 cosine 3x, because it's 6 because I bring out the power 2, then I differentiate sine 3x to give me cosine 3x, 3 cosine 3x. Then my other trigonometry is cosine x, so again, I introduce a new variable term as well, so these two do not work. So is there any other way to integrate this? Clearly there must be a way, right? So we flip through our MF26 and we obtain these four equations. Okay, sine p plus sine q and sine p minus sine q, cosine p plus cosine q, cosine p minus cosine q. The interesting is that if you look at the right hand side, you notice you get a product of two trigonometries, where each trigonometry is either sine or cosine. So in this case, we have sine and cosine. If we look over here on these four equations, it's either the first one or the second one. It's either sine p plus sine q or sine p minus sine q. As such, we can technically pick either one, but for me, I'll prefer to pick the first one because my 3x is bigger than x and the quote-unquote bigger function is in sine. As such, I would like to use the first one because p plus q should technically be bigger. So first of all, you must notice that there's a constant 2 in front. So what we do first, half. Add a half first. Don't forget about this half, okay? Half. Then we proceed to do some simultaneous equation to find what is the value of p, what is the value of q. So we have half p plus q equals to 3x, half p minus q equals to x. Or what I like to do is actually 3 or change it to 1. Why is that so? Slightly easier. I get p plus q equals to 6, p minus q equals to 2. Then what I do is, well, I know that p equals to 4, q equals to 2. How? Well, I add them together, I get 2p equals to 8, p equals to 4, then I get q equals to 2. Okay, now they've done this, so we get sine 4x plus sine 2x, and not forgetting your dx. Reason why I don't really want to include the x in the simultaneous equation because I like to, think fast, easier. So now you realize that, okay, we can just integrate it easily, right? Sine becomes cosine. Okay, negative cosine because sine has n, so then don't forget to divide by the derivative. Same thing for sine 2x, just that it is minus cosine 2x over 2. Last but not least, include the c. You can choose to put a half inside, or you can choose to factorize out more, but really it's really up to you. So you can literally leave your answer as this, or just put the answers, put the factor 2 inside, and this would be your final answer. Take a look at another example. So let's bring these four equations back for you to look at. Let's say I instead change it now to, okay, sine 3x sine x. Okay, just keeping the same number so that it's easier. So now we know that two of the same trigonometrical functions, we will have cosine p minus cosine q. You can only choose one because cosine p plus cosine q equals to cosine cosine, and cosine p minus cosine q is the only one that gives you sine sine. So you have no choice with that. But do take note, there is a minus 2, so I put a minus half in front. Because I have to multiply the function by minus 2, I get back minus, make it times 1, so put outside, put a minus half. Because, now it's the same thing, right? So half p plus q equals to 3, half p minus q equals to 1, yada yada yada, same as last time, which I would get back cosine 4x minus away cosine 2x dx. Okay? Again, we integrate it. So cosine becomes sine, so I get sine 4x over 4 minus away sine 2x over 2 plus c Now I put back in the minus sign and the half sign, although technically you can leave the minus sign out, but I like to add it in. So minus sine 4x over 8 minus minus become plus sine 2x over 4 and then plus c. Okay, so again, in summary, every time you have the product of sine, cosine times another sine or cosine, this would be the formula to follow. And then most importantly, do not forget about the 2. Alright, so there we have it. This kind of concludes the trigonometry integration skills package. Hope you enjoyed.